Crowd Disaster is a game with a bridge builder type game mechanics where you have to prevent crowd disasters by doing construction changes on walls in situations. The crowd disaster kernel itself is based on a partial differential equation that models the behavior of crowds. When starting the game, you have several mission types available you can choose from, and here we pick a scenario called alternate flow, where we have people coming in from different directions at different point of time, and we have to avoid accidents here by a limited so-called crowd pressure. The situation the player is confronted with is a cross-type problem, and if we start the simulation, so we crank up the simulation factor a little to get it faster. First, we have people coming in from the left and the right side, and they all want to go to the green line on the bottom of the scene. So if we put on the crowd pressure, then we see how probability density is increasing, especially at the corner points close to the entry. And a couple of seconds later, we have a second stream of people coming in from the top that kind of add up to the people that already came from the side. And then we lose the scenario because of maximum crowd pressure. Maximum crowd pressure here is the combination of density of people and the variation in space of the walking velocity, which basically correlates to the probability that people are falling and then trample over each other and die. The obvious solution to this problem is to limit the influx towards the central area of the situation. And as a first attempt, we try so by building up walls on the top and left and right part to limit the influx into the central area, in the hope that this will resolve the situation. So that is the limitation on the top part, and we do the same with the left part and the right part, and start the simulation to see what happens here in this case. So people are again coming in from the left and right part, and the influx here into the core area is now limited by the walls separating the arms. But unfortunately, as we will see here, this has a dramatic increase on crowd pressure on the top and bottom part, and also on the left and right side of the situation. So it does not help our problem. The second attempt is to try to use the full bandwidth of these side arms. So the idea is to insert a separating wall here on the left and right arm, to kind of make sure that people coming in from the sidearms into the central area are using the full bandwidth of the sidearms and are not clogging up in the lower part, and therefore adding to the congestion in the moment when people are also coming from the top side. So if we run the simulation, we first see a bit of clogging up at the point where the walls start with the sidearms, and we also have relatively early a little bit of congestion in those sidearms. But we now see that kind of more of the bandwidth is used, and that we don't have that much of a clash of people in the central area in the moment when also people coming in from the top side of it. So we have two frontiers here building up, and if we also take a look at the crowd pressure visualization, there's not that much crowd pressure appearing here, and kind of the simulation goes on, and so the top wave stops and we have more people coming from the side, but it looks like that we don't get here any more critical congestions in the central area. So yeah, kind of inserting sidearms here in the wall eased out the situation. Finally, we can also take a look at all the results that have been obtained for the different scenarios and how things were constructed. Yeah, okay, so that was it. A brief overview of the game Crowd Disaster, which is based on the simulation core of simulating crowd disasters.